Okay guys, so this is test 3, Cal 4 review. So first off, what we're going to be doing is we're going to be doing a triple integral where you convert to spherical coordinates. So not cylindrical, which is just a plane, spherical, which is amazing. I'm so happy to be doing this. But, I have a test tomorrow, so. Okay. So the spherical coordinates that we get are x squared plus y squared plus z squared is equal to 1. So from our definition, we get this p is equal to 1 because p is equal to x squared, well, p squared is equal to x squared plus y squared plus z squared. And then from the same thing, we get p is equal to 2. So dv, which is our, area dx, dy, dz, is going to be equal to p squared sine of, I don't know what it's called, dp, d theta, what is that called, sigma? No. I don't remember. But z is equal to this, and we have the equation sheet, which I'm not going to give you. Just kidding, I'm gonna give you all of it.
Alright. 1, 2, 3. 1, 2, 3. And then there's a little bit of the bend.
Okay. So from the first one, triple integral, and we get x is equal to p sine, cosine, y is equal, but pretty much dv is equal to this. So our limits is 1 to 2, it's spherical, so it's going to be 0 to 2 pi, and then the one bit I don't really understand is this, and it's 0 to pi. Because we don't have a dv, I mean dx, dy, dz, so you can't really convert. So I'm guessing this is just the upper half of the quadrant. And yeah, I guess that's it. So the integral we get after substituting everything in is 0 to pi, 0 to 2 pi, and 1 to 2. And it's p cosine of what, theta? Yeah, or what is that called? And then dp, d theta, I'm just going to start calling it sigma. So if you look at this a little closely, you can notice that we can do something fun. It is separable, so we can separate it. Now, there's not really enough room on my whiteboard to write out all three, so I'm just going to write out what they become. So we have cosine of sigma. Okay, so that's first on, so cosine becomes sine of pi minus sine of 0. And from that, I talked about this in the Cal 4 test 2 review. From that, we see that it's 0 because all of the integrals are multiplied by each other, and sine of 0 is 0, and sine of pi is 0. So from that elementary step, we can figure out we don't have to do anything else, and we can just set it equal to 0. I didn't even think about that. I just discovered that. I wrote down everything I needed right here, doing all the stuff. Wait. Oh. Oh. Oh, shoot. Shoot. 0 is the answer. Little spoiler. But, I forgot right here p squared sine of sigma. So, now we figure out, oh, it's separable. Oh, but here's a question. Is sine of sigma and cosine of sigma, do we want to integrate that with the by parts or product rule? I don't know, I don't remember. But I know one thing, we can't do that. So this and this equal 2 sine of tooth. Right? No. Wrong. It's close to that, but is divided by 2. So we're taking the integral of that, and p to the third. Let's see though, where's this equation sheet? So that's one of the trig identities. So the reason why is it's sine of 2x is equal to 2 sine x cosine x. And the x doesn't matter, it's just a variable. And that's the variable. So if you just divide by 2, you get that. Okay, and now we know to take the integral. Okay, well, I'm still going to stick with that first train of thought. Yes, you can integrate all that stuff, but we're going to go straight to this part. We're going to go straight to, what does that become? Cosine of 2 sigma? Is that it? Yeah. It's negative. I think she did it wrong. Why did she factor out 1/2? Oh. Yeah. Because we're not doing chain rule, we're integrating. So when you're integrating, it's 1/2 out in front over 2. And I'll integrate those other ones just for fun. One just becomes sigma, or sorry, theta, 2 pi, 0, so it just becomes 2 pi. And then the other one is p 1 to 2, p to the 4th, so it becomes 1, or not 4, becomes p to the 4th over 4. And then that's integrated from 2 and 1, which equals 4 minus 1 fourth. Right. Oh, you can factor it out. You can factor out the 1/4 instead, and you can make it 1/4. Because, I mean, for any integral, you can just factor it out for some reason. And you can make it 16 minus 1, which, 15 over 4. But that doesn't really matter at all. And cosine of 0. So this becomes 1 because cosine of 0 is 1. Cosine of 2 pi, that's that's also 1. I was thinking pi, but it's just also 1. And, you know, it's negative. But negative 1 plus 1 is 0. So, from doing that, we have learned this integral cancels out everything else because it's 0. So our answer is this 0. Alright, on to the next question. Try to speed it up. Okay, everyone, so this is part A of question 2. Alright, so we have to solve the system first, and then we have to find the Jacobian, which is just the cross product. Cross product is something you learn in Cal 3. And it has a lot of uses. So, yeah, okay. First, you have to solve for y and x. So, first we have this. Which one did I solve for first on this one? I solved for y. Well, I can solve for. Alright, what are we doing? We're getting x and y in terms of u and v. So y is equal to x minus v. Okay. Now we plug that in to the u, and we get u is equal to x plus 2x minus 2v. Okay, well, we got it in terms of u and v and x. We're trying to eliminate the variables. I'm sorry, I'm tired, guys. I've been doing this all day. V is equal to x minus y, blah blah blah, 3x minus 2v equals u. So x is equal to, what is x equal to? U plus 2v over 3, and then all you have to do is plug it into y. So what you get is, that's kind of annoying. That's why she did y first, I think. Well, I got the x correctly. Well, let's just plug it in. Okay, it just becomes negative 1/3. So y is equal to u plus 2v over 3 minus, minus v. Gotta differentiate them. Okay, and then this is our system for that. Y is equal to u over 3, and 2/3 minus 1, negative 1/3, negative v over 3. So that becomes, if we simplify a little bit, u minus v over 3. Okay. Second answer. Okay, Jacobian. This is equal to dx du. Yeah, dx du, dy du, dx dv, dy dv, do? Just plug in, so dx du. So take derivative of x in respect to u. So the v disappears, and what we get is 1/3 dx dv 2/3. Okay, dy du 1/3 again, negative 1/3, and cross them equals. I'm right on that, yeah. Okay. Negative 1/9 plus, no, minus 2/9 is equal to negative 1/3. Okay, that's part A. On to part 2. Okay guys, this is part B, so we're gonna go through it as quickly as we can. Okay, so we're finding the image of the triangle, and the boundaries are y is equal to 0, y is equal to x, and x plus 2y is equal to 2. And from that we get this line, y is equal to negative 1/2 x plus 1, and these are the uv, y, and x's from the last equation. So the image of y0, so from that we get 0 is equal to u minus v over 3, and which means u is equal to v. That's one of the images. Okay, and then u minus v over 3 is equal to, because y is equal to x, u plus 2v over 3, so that cancels, u cancels, v is equal to 0. Yes, I am correct. And let's see, this last one, that's kind of annoying, but whatever. U plus 2v over 3 plus 2u minus 2v over 3 is equal to 2. So 6 is equal to 3u. Yeah. Okay, so u is equal to 2. Okay, and that is correct. Okay, so y is equal to x. This is the first one. And y is equal to negative 1/2 x plus 1. So plus 1's about there. I would say it's a little bit of a slanter angle like that, but you know, whatever. Yeah, so we're finding that. That's what we're graphing, and okay. Okay, and then to find the other image, we find the UVs. So V is equal to, oh my gosh, I messed it up on my test, and I messed it up on this. I have a little triangle down there. Okay, but V is equal to 0, and U is equal to 2. I could do it either way, but so this is u is equal to 2, and this is v is equal to x, and this is our triangle. Boom. That's part 2, part B. All right, on to number 3. Okay, guys, so this is problem 3. This one I like because it's a little more simple. You only have to take one integral, but it's a line integral. So we have to do all the way back to Cal 2, and you know, they gave us the equation, luckily. And it is line integrals in space. The integral of c of fxyz ds is the integral from a to b of f of gt, ht, kt, square root of dx over dt squared, plus dy over dt squared, plus dz over dt squared, dt. So pretty much what I did is right here we have our r of t. It's 2ti plus tj plus 2 minus 2tk. And here's our interval, 0 to 1. Great, very great. X is equal to 2t, y is equal to t, z is equal to 2 minus 2t. So dx, dt, 2, d1, negative 2. And all I gotta do now is substitute 0 to 1. Yes, okay. 2t times t. I am going to use little dots for my multiplication because it's going to take me a while if I don't. And differentiating t's and pluses, good luck. Y, so t plus 2 minus 2t square root of 4 plus 1 plus 4, which is the square root of 9, so that's 3. So 2t squared plus t plus 2 minus 2t, so it's 2t, so it's 6t squared minus 3t, and then plus 2, so plus 6. Am I correct? Should be correct. Oh, well, they, on the test, they pulled the 3 out because it's multiplied times everything, but whatever, I did it my way. Okay, and now just take the integral, and it is 3t, oh, never mind, it's not 3t, it is, yeah, it's 2t to the third over nothing, because I already did that, minus 3 halves t squared plus 6t, as integrated from 1 to 0, and what we get is 2 minus 3 halves plus 6. 2 minus 3 halves? Yes. Okay, great. So we get, what I did is 8 minus 3 halves, so 16 over 2 minus 3 halves, and that's equal to 13 over 2, and that is our answer. Alright, that's it. Okay guys, so this one I wrote out a little bit because it's got dot product in it. So we're finding the work done by a vector field F over C. So that looks like the integral of C F times dr. So what that is, oh, okay, and here are our parameters. F of xyz is equal to 2xy I plus yzj plus zxk. And then we have our r of t, which is t to the third, t squared, 1. No, sorry, t. I'm getting confused by the pluses and the t's. And our very easy limits are 0 to 1. So, this f of c, let me look at the equation sheet real quick, just to make sure I know exactly what I'm talking about. So, line integrals of vector field work, circulation, or flow. So, yes. Okay. That clears it up. So, f of r of t is our vector field, and, well, it's not really a vector field. Our vector field is the vector we get from, or the point we get oh, we're finding work. So it's going to be a scalar thing. It's not going to be a vector, which is a work done in a direction, magnitude and direction. We're just finding magnitude. Boop, 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 boop. So f of rt, what you do is you just plug in rt to f. So t to the third, t squared, and t becomes 2t to the fifth, because it's t to the third times, oh yeah, t to the third times 2t to the second times 2, because we have that there, and then t to the first, and t squared, t to the third. T to the third times t is t to the fourth. And then we do dot product. And our r of t, r prime of t, is, our r prime of t is just the derivative of r prime. So, or r. So it's 3t squared plus 2t plus 1, pretty easy. And then you dot product it. And dot product brings a vector, it makes two vectors into a magnitude. Well, and not into a magnitude, but into a thing that's applicable into a magnitude. So you do the i's times the i's plus the j's times the j's plus the k's times the k's. And from doing that, we get 6t to the seventh plus 2t to the fourth plus t to the fourth. Wait. Oh, I guess I didn't reduce. It's 3t to the fourth, actually. This is problem 4. So it is, yeah, it's 3. Okay, now I'm just gonna skip that step, and I'm just gonna evaluate the integral. And what we get is 6t to the 8th over 8 plus 3t to the 5th over 5. And that's 1 to 0, which 0 becomes 0, and 6/8 plus 3/5. Quick maths. I can just cancel out that, so it becomes 3 over 4. So equals 3 over 4 plus 3/5. Multiply both. I'm not doing that. You get like, oh wait. You get 15 over 20 plus what? 4 times 3, 12 over 20. And that's equal to 27 over 20. Hooray. Am I correct? Yeah, I'm correct. Alright. That is that's finding a magnitude of a vector field, which I've done in fluids, and honestly it's coming back to me now. But pretty cool. Okay guys, so if f of xyz is equal to yzi plus xzj plus xyk, find a function f such that f is equal to delta f, or gradient f. So here I just restated what I just said. Gradient f is equal to fx, fy, fc. So from this, we don't take the derivative yet. We just find, so f of x in this is just the x of the x. So f of x is yz, f of y is xz, f of z is xy. And from that, we take the integral in respect to, in this case, we're doing fx, so we're going to take the integral in respect to x. And what we get is xyz plus a c, which is going to be gyz. Then we take the derivative of that in respect to a different variable. and we get f of y is equal to xz plus g prime of yz. And it has to be one of the variables in this, I'm pretty sure. Yeah. So it's either y or z. And from that, we get xz plus g, or there's fire sirens outside. Xz plus g prime of yz. And then we set the fy, the derivative of fy, back to the original. So we get yz, wait a minute. I did something wrong. Yeah, we set it, we set it equal to fy because we're taking the derivative in respect to y, so it's xz. So subtract them, c is equal to 0. Well, g of y of prime. You do the same exact thing here in respect to z. Set f of z equal to the original f of z. You get h of z is equal to 0. And from that, we can set g prime of yz equal to h prime of z. And from that, we figure out it's not a 0. There's a constant there. And from that, we have to add it on to our gradient f. So, our gradient f is, you know, the original equation. Wait, where'd that plus 1 come from? Okay, I'm not entirely certain. What am I doing? Oh, that's wrong. That's wrong. That's just entirely wrong. Oh. Okay, so our f of xy, our f of xyz, yeah, okay. So we're not looking for this gradient f in the end, we're actually gonna just find f, and its f is equal to x, y, z plus c. That's part A. Part B, I'll just tell you right now, is evaluate using f from part A. So, okay, really weird section here. Really, really weird. Okay, so we get this is equal to this because we're evaluating this with the f from part A. So what we do is we just ignore because this is what this turns into. We ignore that, and what we get is f of 3, 5, 0 minus f of 1, 1, 2. Because this is like the integration form of it, right? No, it's not. What am I even talking about? This is parametrization, I think. What is this? I don't know. It's gradient. It's all that stuff. But from the end, we get from that, we get our answer. So 0 right here, plus c, and then 2 plus c. So, you know, a little trick is these c's right here cancel each other out because it's c minus c in the end. And our answer is just what's remaining over, which is -2. All right. Okay, guys, so this is the last one, and this is Green's theorem. So we have some bounds. We have y is equal to 0, y is equal to x is equal to 2. And then we have this crazy integral, but all we're going to do is make it into a double integral because we have a dx and a dy anyway, so it kind of needs to be a double integral. But we're going to do dn over dx minus dm over dy, dA and r, and our bounds are going to be r. So our m is going to be the dx, or whatever is in the x placement. And that is y cosine x minus xy sine x. And our n is 3x squared y plus x cosine x. So when we take the derivative, because we have dn dx, our n, it has a product rule right here, which sucks, but it's quite easy. So we right here, 3x squared y becomes 6xy, and then the product rule is x times negative sine x plus cosine x times 1, because it's lefty right plus righty left. And then we subtract the left side, we subtract the m. So m over dm dy. So we have y cosine x, so that's just cosine x. And then x, y sine x, so that's just x sine of x. And from that, we get something that just cancels out. So the cosine x's cancel, the x sine of x cancels. So what we end up with is 6xy. Yeah, that's it. Okay, and we are going from y first because we have the bounds from y, so it's easier to do y first. I mean, actually you could do 2 to x, but we're just going to do 0 to 2 for the x. And this is dy dx. And that first one, so the reason why this isn't separable, and it's something I haven't highlighted on, is because in the bounds is one of the variables. We just can't. So the first one is x. That looks like a T. So 3x. So what it becomes is the integral from 0 to 2 of 3x to the third and dx. So that becomes, I'm right on that, right? Yeah. Yep. Comes 3/4 x to the fourth. And evaluated at 2 and 0 is 16. Actually, the 2's cancel, so it's just 3 times 4, and that's 12, and that's your answer. Alrighty, that is all for today's Cal 4 video. I have a few more things, but I really need to stop making this video and just remember everything because I have about 12 hours until my exam, and I need 10 hours of sleep. Well, 13 hours to be specific, but yeah, 10 hours of sleep. So that means I get like 3 more hours of studying, which is actually a lot of time. But I mean, I haven't been spending all day on this exam. should have spent some on my fluids exam, and I'll be making some videos about that tomorrow because it's on Wednesday and today's Sunday. But alright guys, I hope you enjoyed the Cal 4 review for test 3. Hope y'all do well on your test.